okay. I'll try to. Okay, blah blah blah. This is the kind of boring stuff which I then probably will skip and focus on the real sharding stuff. Oh, that is the first thing that I should probably mention, which applies to what there are a lot of, I think, people out there which are looking to solve all these large-scale solving problems by coming up with some silver bullets in marketing or vital for people's products. And I would say there is none, right? If you look at if it's MySQL cluster or some continuous sequence guide, Kickfire, using some MySQL proxy stuff, well, nothing of it is a silver bullet for scaling the application. So how do you grow your MySQL applications quite typically, right? So if you look at most applications, at least applications which people really develop from the ground and from kind of zero traffic, they start with single MySQL instance quite typically. All in the same box, so maybe MySQL here, Apache there, but it's going to be a single MySQL instance. In this case, things typically become limited. It's either by CPU or by disk I/O capacity, which is at the same time its memory typically, right? And what is interesting here is it's not only what really hardware which limits you, but MySQL itself is also not often capable of scaling, right? I mean, if you have just 8 cores, well, you'll be able to use some of them. If it's like 16, well, your luck will probably be worse. Now, scaling up is also, in any case, is limited and expensive. I mean, you cannot get servers with unlimited amount of memory or unlimited amount of cores. And what is also important, it doesn't really possible then you are looking for a single thread performance. I mean, if you look at that, the CPUs you get like in your laptops are probably just going to be like maybe 2-3 times slower than the fastest core you can get. I mean, there's just things just don't get any faster for a single core, and that is a big problem because in a lot of cases you may be caring not only about the throughput of a box, but about single query performance or single thread performance. Like your MySQL application goes through a single thread, right? So how do people go from this one? Well, there are two basic choices. One of them is functional partitioning, another is replication. Well, I'm speaking here about the simple choices which you can implement like over a weekend, typically, right, without the big changes. So what is the functional partitioning? Well, you had your application, maybe of different components, like you had your main application, your forum, your blogs, all not crowded in the single database instance. But you really don't have to. You can really say, okay, enough is enough, I'm putting different applications on different database boxes or different components, maybe change a few connect strings. That's it. Your data accesses are really clustered across those databases which are independent, clustered across those functions. And then sometimes you have to work around one of your joins, maybe do some hack to federated tables, but that's make it easy. The challenge here is, first of all, those partitions, the functional partitions, tend to grow too large on their own. And typically in application you would have something, some chunk of data which becomes too large, like, let's say user-generated content on forums just blows up, right? Or let's say messages in some social networking application. That is, messages what takes, or like comments which take a lot of stuff as a single piece. Even if you put that single table on a single server, you will get in trouble. And also, you can, with functional partition, it's fun because you can get to a certain level easily, but then going forward becomes extremely complicated. Like, these tables are just too tight together and have to change everything if I have to put them on different servers. Interesting thing here is when you you come to functional partition, you also got to do more about the fault tolerance. What I mean by fault tolerance is, of course, you want high ability in terms of if my server goes down, nothing happens because there is some backup server which is called standby or wherever you have somewhere to fall back. And the fault tolerance is somewhere step further and say, okay, what if there is none, right? What if you did something nasty and let's say this, maybe you screw up and did some update which was replicated or something, right? So the fault tolerance is what we are when we are trying to design application, and that's really more application design technique. What if there are some functional components are unavailable, the stuff is still up. For example, if your forums are down, right, and you may be doing some queries to forum database from your front page side, well, to get like hot topics, your front page doesn't have to be down just because of that, right? The next thing that people are doing, actually I have a choice, and a very good one, is MySQL replication. The concept behind MySQL replication is, wow, the web applications quite typically have a lot of reads, more reads than writes. This is not necessarily true in all cases, because if you look beyond MySQL, then you'll find what in a lot of cases there is such thing as memcache in front of it. And memcache can be able to offset like 90% of your reads. So your application, which was like 90% reads, 10% writes, becomes, you know, about 50-50. So that's the point. Another thing, what is the trouble with MySQL replication is that it is asynchronous, right? So that means your data is going to be updated on the slave sometimes, typically within microseconds or milliseconds, but it may be seconds or even minutes. And that means you have to deal with your application reading their stale data, right? Also, it doesn't help to scale writes, because all the writes which go in the master have to be done on the slave, and is even further. It's even worse, because all the threads which run in parallel, all updates which run in parallel on master has to be serialized when they execute on the slave, right? And this is very bad. It doesn't allow you to use a lot of cores for replication. It also cripples your ability to use multiple disks, because it will only pretty much issue one read at a time. And if you have like 25 hard drives there, which all can be loaded, they won't, right? Because there's only one request to deal in parallel. And another problem with slaves for large scale growth is, of course, their caches, because if you look at that, then slaves share the same data, and also the cache, the memory which is on those slaves, is going to be highly duplicated. So let's look what you can do about those problems. First, about asynchronous replication. What people are doing? Well, there are multiple ways. One of them is, say, I'm going to route my queries. These queries are sensitive, and these are not. I can read stale data for some queries, but not for others. Right? That's one choice. Another choice for us is, and this allows you to spread every so much queries. Another way to go further and say, let us look at the session data. What I mean is, let us go back to this forum example. You have someone who just posted a message. This guy probably should see his message, right? But the guy who is also browsing the site and who didn't try to it, he perfectly can read the data from the slave. And if he will see that message in 2 seconds or a minute, probably nothing happens. There are still some tricks here, like for example, you have multiple slaves and they could be all in different positions. Then you have to maintain some kind of slave persistency, right? You don't want user to become crazy, like pressing reloads and seeing his message appearing and disappearing because it's being read from different slaves. Right. It also allows you to do some things with avoiding the stale data. Like you can say, okay, I have, did my updates and when I did my update, the master was on certain binary log position. And when you're reading data from a slave, you can also get a position and say, wow, this slave is already up to date, even for its slave. And if I just did the write 2 seconds ago, this data slave is already valid for me. Another way is to do some sort of versioning. Let's say you can say, in many applications there is, let's put this way, some main object, right, or root object I would call it. For example, for many social networks you can say, oh, that's my user. There are changes for user profile, changes for like new posts by users, comments to the user. I can this as changes of this global user. What that allows me there is to store modification information for that user object. And then if I'm reading the data from that user object which wasn't changed for last time, or for every so much time, I can read it from the slave, right? Or I can actually use the binary log information as a version of the object. That allows me also to figure out what can be read from a slave and what is not. And very interesting here is their integration you can do with memcache. You can actually cache the object versions in memcache aggressively. And because, let's say if you're speaking about stuff like user, what I'm speaking about, like millions, 10 millions, I mean, this is not a whole lot of data. It will perfectly fit in memcache, and you will be able to retrieve that information very quickly. Another item to mention here is MySQL proxy. There is work going on in MySQL proxy to split reads and writes, and that will be also quite interesting and simple solution so that it works well. This is, and one thing I don't have on the slides here, which I remember that I did the talk back when, but there was no space on the slides, anybody find it, is what this is all synchronization which is done on the read. You can also do the similar stuff on the writes. For example, you may see what a lot of your updates are not critical. For example, you're updating the counter of page views. Who cares, right? But there are some updates, I don't know. For example, you say, oh, this is news which is no more true, right? I want to ensure nobody ever sees it anymore. Then you can, instead of doing all this stuff, to make sure all the slaves are caught up. Say, okay, I'm doing master post wait pretty much on all my slaves, and I only will succeed in executing this command, then this operation, then all my slaves are up to date. Does that make sense? So there is master post wait command which allows you to wait until the slave has caught up to given binary log position. So you can do a date on the master, record current binary log position, and then do master post wait on all the slaves for that position to make sure they open. Now, replication and writes. We mentioned what replication is not good for scaling writes, but not everybody recognizes how bad for scaling writes replication really is. I mean, it's very bad, meaning as soon as your slave becomes busy, let's say like over 50% with writes, it's going to degrade very quickly. Then you get, let's say, to like from 50% to 90%. Well, your load is not even double your write load, but your slave capacity like drops 5 times because each could had like this 50% free resources, and now it only has 10, right? And this, of course, oversimplification. As I mentioned, actually things are even worse because if your writes, if your master is really 50% saturated with doing writes, chances are your slaves are already unable to catch up because of a single thread. So, what's about optimizing MySQL replication? What do you do if MySQL replication cannot catch up? Well, first I would say it's a very good idea to use the patches from Percona, or you can use our Delta builds, which also include them, to use the slow query log patches written by us. What we can do is we can log the queries from replication thread. And we can also get the log of all the queries, which we can summarize, analyze, and can see, oh, this is actually, I'm running millions of these updates, which happen to be updating very random portions of table, and they are slow. That is what my replication thread is spending time doing. And then you can think how to optimize or get rid of these given queries. Because many people are like, oh, my replication thread is not catching up, so what do I do? How do I figure out where should I focus exactly? Right? Another thing is what you can try out row-level replication MySQL 5.1. In certain cases, it's faster, in particular because it doesn't have to search for rows on the slaves. In some cases, where performance bottleneck is associated with really doing updates. In other cases, it's finding the rows to update. By the way, how many of you run MySQL 5 row-level replication here?
5.1.
5.1, yes. Okay.
Well, they're using mixed, which is disaster.
Okay. Okay, so not too many. And so if you're not venturing with MySQL row-level replication yet, you can also kind of emulate some of what it does. Like, for example, I often see insert select and some very complex reporting group by query, right? Or maybe update with select and stuff like that. I mean, even it could be simple update with complex where clause which does full table scan. Instead of that, did what we didn't teach you in school, right? Fetch the stuff to the client and then do updates by primary key. That will be very similar to what the MySQL row-level replication does for you. And that, I mean, there is really no good reason why you want to find all those rows on each of the slaves. The other thing here is dealing with latency. You typically want your slaves to be relatively up to date, right? And you can typically get more use of a slave, which is relatively current. So, first of all, it's important to understand, as we have single thread, complex queries, or long queries, long transactions actually, will serialize. So if you have some transactions which takes 5 minutes to run, then your replication will be delayed 5 minutes a peak. So you have to get rid of those. What do you do? Well, first of all, you can chop your query. For example, you need to delete the data where, let's say, some old data. Well, in these cases, you can do, instead of one query, run in the loop, delete it with where clause limit 100. Run it many times until you will see no row deleted. And do it in different transactions, of course, and you will see your replication problems gradually reduce. Now, it's also a good idea to, in many cases, to do it separately, right? You can actually do select to fetch all those row IDs, and then do a bunch of multiple deletes with in clause to do the updates. So, alter table, and that's another piece, right? The good thing with alter table is there is no need to do that via replication. You can quite perfectly do it locally, and also because it takes so much time, it's often a good idea to do some switching. For example, you can have master node where you do alter table on the slave node, then you pretty much wait for catch up. You switch to the slave node and you alter the former master node. I mean, it helps a lot, especially if you deal with very long alter tables. Another thing is what you can do and say, well, how do I get my replication multiple threads, right? And in many cases, you can identify those like couple of queries which cause you a lot of problems. And what you can do with them is to run in parallel. Instead of doing them really for replication, do like inserts in some task table and have a little script on the slave which simply gets records from those task table and applies it locally. It works very nicely, and it really allows you to do other nice things like, oh, what if I want to, let's say, delete the data after over so often from master and all the slaves, but not my archive slave. You can do this task table, but you can skip doing that for the archive slave you're interested in. What I mentioned also before is how fun is verification to deal with caching, right? If you have, let's say, 20x database and 16 gigabyte box, then chances are you will almost have completely cached workload, and it will fly. Now your database grows to 100 gigs, and you say, oh, let me use like 5-6 times more resources for this database size, and you add 5 slaves. The problem is, on each of the slaves, only like 1/5 of the database now fits in memory, and so it can be much more I/O-bound than before, and so your real capacity haven't grown. You can improve it. You can do various ways, and I'll do this on the next page, but it never gets perfect. It's also important when there is a storage level duplication. And I'm hearing sometimes, oh, storage is cheap, who cares? Well, it depends on the storage. Like I have a customer who has like 50 instances and they replicate terabytes of data, and each of that instance is like external enclosure with like 20 hard drives. Well, believe me, they don't think the storage is cheap. I mean, of course you can grab a hard drive from a shelf, which is 1 terabyte, and say, oh, I can put everything here. Well, it is, right? But you need IOS. You don't care about the size. Right? So, that is one thing. And now we have such fun stuff as solid state drives coming out, which are even more expensive. So, you don't want to have too many of these copies at the same time anyway. So, I mentioned about caching. What can we do to improve caching with replication? Well, you can use slave roles, right? For example, your reporting queries may have different working set from the normal OLTP workload, and they can be run on the separate slaves, or there could be dedicated slave, probably with like MySAMPles search indexes right on the other slave server. Another approach is do query routing. I say, okay, let me pick. If it is the user from a given session, let him hit the same slave server. And it is good anyway because you don't want any jump back and forth in the timeline for this user. But it's also good because same user is probably going to go through, same. I mean, he has same interest. He reads the same bodies. He looks at this. I mean, the same profile page. So you will have much better cache hit ratio if you stick this user to the slave server. Of course, you have to be careful because that slave server can go down. But if everything goes well, that's works much better. Another thing here, what I mentioned. As an example, you can use even user ID and old user ID if you have 2 slaves. Well, in fact, that is often not very good because you should understand how databases cache the data. And they really cache the data inside buffer pool by pages. So if you happen to have interleaved data files, let's say even odd, then you cache a page anyway. You just never touch some of its data. So in some cases, it may be much better to do, let's say, odd thousands and even thousands, or some other, let's say, physical data stored over caching method. Another problem I should mention, and why this never gets perfect, is writes. Because if you get significant writes going through the replication, those writes are going to have considerable working set themselves, and they will keep that in duped in all caches. Okay, so enough replication, and that's good. So you have some time for sharding. So when we go and use sharding, well, typically I would say people do it when functional partitioning doesn't help, and replication doesn't help. People are using sharding, and I would would say the current trend what I see is people had, read, heard, and otherwise learned about this hot buzzword sharding too much. So they start to shard the application even like for their homepage. I mean, before you really look into sharding, I mean, you should really understand what, in many cases, it's going to complicate your application development, and it will put you handcuffs. These features are, which were easy to do in the single instance, are now extremely hard to do, right? So think hard if you need it. I mean, a lot of us who deal with, I don't know, like Alep's top 1,000 websites, we really need sharding, right? But the rest of us can probably get without it. And I was, for example, surprised to learn what YouTube, up to the point of Google acquired them, they did not use sharding. They just used like very advanced replication techniques. And what is also interesting here is what as the systems evolve, now we can fit more and more stuff on the single system. For example, like I would say the classical live drone presentation, say they took about sharding. They're speaking, oh, we have these like powerful boxes with 4 gigabytes of RAM in each. Well, these days, like for the same maybe like 15K, you can buy a box with 128 gigs of RAM. I mean, so you can fit 30 times more data in it. And so a lot of replications, a lot of applications which really couldn't continue without sharding a while ago can perfectly live on the replication now. Right. So sharding is good, but think really if you need it. So what I mentioned is, it's of course need careful planning. It may be hard to implement, and especially if you don't design applications for sharding. And also it depends a lot on the structured application. Like if it is something which is completely separate, right? There is no data interactions, then sharding can be very trivial to do. When you're doing sharding, the most critical question is how do you really shard the data? Okay, yeah, that's what I told some of that too fast. But I still have to talk about the sharding here. So what makes people to decide to shard? Actually, it's not only performance, right? It's single phone box performance obviously goes first. Replication capacity, which can be very different, as I mentioned already, is another reason. And then third is also maintenance, which is painted MySQL. You have like huge inactivity table, for example. Oh, it may be something like you cannot add the index anymore because it takes 2 months. And you have to break it down in smaller pieces anyway to really make it maintainable. Or you may have other challenges like doing your backup and recovery with some strict recovery times. I mean, it may not be easy to say, oh, from this instance failure I have to recover and get back in, let's say, a couple of hours. And for large-scale backups, it's possible, right, using some systems, but it may be very expensive on its own. Now, when I put things like sharding and replication, it's really and, because when you use sharding, you're most likely using the same replication, at least for high ability, and then also I mentioned for operations needs. And what matters here is the more servers you have, there is a larger chance at least some of them will fail. And people usually have a strange requirement, like where they want the application to be highly available, right? So it's not like, oh, even if we affect only 5% of our user, then this box fails, we still don't really want that to happen. So you've got to replicate. The interesting map here is, the last thing I heard from Google is what they have about 2 2,000, I think, machine days per failure. So in their case, each MySQL server crashes approximately once per 5 years. So if you look at that, that is a really great mean time between failures. I mean, and this of course includes running on the RAID and decent hardware, but this is great. And that means, funny enough, if you have a decent system and decent hardware, and your provider doesn't have this, power losses, then you may never see failures, right, or MySQL driven. Quite likely, bugs in applications and stuff like that, they are or operational screw-ups are quite more frequent than the MySQL crash itself. But at the same time, as you get to a scale and get to 50,000 servers, then the application bugs, they worked out at the same pace, right? And admittedly on, but the mean time between hardware failures is not going anywhere, so you'll see more of them. I mentioned master-master replication, ease of use, easy to do with operation systems, and then I speak about master-master, write to single master, avoid the problems. Some people say, oh, I can save a bit of this by, let's say, running to 2 master instances, because now I can have a bit more write capacity, because now I have 2 replication threads which are pretty much running at the same time, right? There is no serialization. They still both have to do all updates, but at least there is only, let's say, half updates which have to be serialized in single thread. The problem is, even if you have like your smart application, you call it around so there is no conflict, let's say you update different databases, it's still pain. What if your application screws up for some reason, breaks? I mean, things happen, right? You maybe lost your binary logs because for some crazy stuff, right? You removed your own logs. Well, if it is master-slave, oh, I see somebody here removed your own logs, right?
No, I
You did? Okay. Yeah, that just was that look. So, the point is, if it is master, active master, passive slave, which is not being written to, then I can just take LVM snaps on the copy, right? Or even copy the data in binary form some way. If not, then I have this pain of merging the data together. Even if you say it's different database, so it's in theory easy, then still extracting the InnoDB database is a pain, right? I mean, you cannot really do binary copy anymore. So how do we shard the data? The point is very simple. What you want all the most important queries to run within the same shard. That's the first point. And the second point is that you can control shard size to be what you need it to be. So for example, sharding by user ID is a good choice, and sharding by country ID is probably not, because there are some small countries as China, India, United States, right, which will consume a large portion of the data and large portion of the traffic. It's also quite frequently you would need more than one speed at a time. I mean, you shard your data one day and another day at the same time, and simply have some portion of the data duplicated. If you do multiple sharding, then you can either store a full data in both cases, or store simply pointer to the data. Let me give you an example here. Imagine you have a website which is about books, and people leave comments for books. And you have 2 different pretty much access paths. Like you have the guy who would, oh, here are my book reviews. I read this book and that book, I read this book and that, and so on and so forth. And there is another access path by the book. User can have a lot of reviews, right? Book can have a lot of reviews. And you want to have it clustered both one way or around. What you can do and say, okay, I'm going to store stuff here and there at the same time. Alternatively, what you can do, you can say, okay, on this my user, the user is my primary sharding, and then the books is my secondary sharding key. So for books, I'm going to store some minimal data, for example, the date, because I'm going to sort by date anyway, right? maybe the title, right? Rating, some basic info, and then the pointer which shows what really this is the review number 74 for user number 25. So when user clicks to see a full review for a book, I can really go back and retrieve a full review content from somewhere else. Now, the next thing about the sharding is how do you distribute your data? One of them is fixed hash. I mean, very simple. Say, okay, I have 5 servers. We go depend on the division by 5, right? It's very simple, but it's very inflexible. And even if you use stuff as consistent hashing, you have to remap a lot of things to other servers. So in practice, you don't want it. The next approach is a data dictionary. In most cases, there's primary object like user. I mean, you wouldn't have too many of those. Like you have like millions, maybe 10 millions, right? Maybe it's more than that. Right? It's still not that big of a deal compared to data you store for each of the users. So you can store pretty much information per user. Oh, this user goes to this shard, and that user goes to that shard. That makes it very flexible to control, right? And you can have it, in theory, the dictionary to become a bottleneck, but really it doesn't happen because dictionary is small and you can use them cache to cache and stuff like that. So that's very rarely for dictionary really become a better. The other approach is to use a mixed hashing. So when I would use mixed hashing, for example, we have little applications which store information about the links. The links from page, like 2 page, right? And really, we want to spread these links. The challenge here is there is huge amount, even on pages itself, right? So even if you say I want to shard by page, there are billions and billions of pages on there, right? So in this case, having the dictionary which stores, oh, each page goes to this shard is not practical. In this case, we can use some combined approach. We can hash this user ID to buckets and say have a million of buckets. Each applies to, like, let's say, thousands of URLs. And then we can map those buckets to the given servers, which kind of gives us both flexibility because now we have we can manage large amount of pointers at the same time as we limit our dictionary size. And then I also see some people which did shard it in some like strange way, like they would often, for each object, they will identify it by shard object ID. So in any location you could point to somebody else, and as you could probably guess, those guys were using Java, which only does like lookup by primary key or stuff like that, because I mean you cannot really do any experiences. Another good question is tables and charts. So how do we usually do relationship here? One approach is to say, okay, each user ID, as an example, gets its own set of tables. And this is very frequently met, and people are using some, for example, open source applications for massive hosting. For example, you would take WordPress or, what's that?
WordPress is a good example.
Yes, WordPress, forums, and stuff like that. And then it has huge amount of tables. And then that is where a lot of problems start, because, well, MySQL is not good working with many tables. And then many, I mean, like really many. You have, for example, hundreds of tables per user, right? And you have a million of users. Well, I mean, even let's say hundreds of thousands of users per server. That is going to be 10 million of tables. That is a lot of stuff to deal with. Another approach is to say, okay, well, let me keep single set of tables per server. And this is most frequently met in some legacy applications which had the sharding added later on. They have their queries, for example, hardcore a database name and table name. And nobody bothers to go through and change it everywhere. So you keep one set of database per report, but that's again not really flexible, because if the smaller instances are good, right? But small instances with small tables are good. What I really like is having somewhere in between and say, okay, I have multiple table groups, which can be called databases, or the name thing doesn't matter in this case, are per server, and there are multiple users or sharded objects in each of them. It really gives you a bit of pain how you do query generation. But usually if you do a sharding, you already have to go through many of those pains anyway. So that makes it quite nice. And this is really flexible. Another question, how far are we? Oh yes, not too much. Anyway, so good question about capacity planning, right? So how do we plan capacity for different boxes which have different users mapped to them once they go around? First of all, I would say it's very good if you don't use fixed attention and can really add shards as you need, and like enable disable them. Then it's important to add the space for growth, because if you will put the traffic on the server until it starts to be slow and then start using something else, the chances are, as the data set grows, right, or users on the shard become more active, it becomes overloaded. So you need to know space for growth. It's also important to understand historical part of how we use people, because there is another concept which may be happening, and for some applications more often than for others, is when we have a lot of users who start playing with applications and then they leave. So you can have a spike in this shard growth, and then it goes down, so you can put another wave of users to it. I mean, of course, probably your marketing guys would like it if your users just play for application in a week and then leave and never come back, but that is a reality for many cases. It's also important to consider data growth and access pattern, right? So how is your data going to grow? Do you have enough of space simply per shard to hold it? And what is about your cache, right? Is because if users are going to access a whole data set, it is completely different than if the data set grows, but still people are accessing the data for last month or so. And what is also important to understand, whatever capacity plan you have, large chances are you will need to balance the stuff sometimes. There is always learning, I mean, it's kind of learning stuff, you always find some stuff, oh, I didn't anticipate, now this stuff is overloaded. Another thing that applies to this simple sharding is data archiving, which is in particular used by some larger systems. So the idea is, as I mentioned, in many cases, people don't care about the state data. For example, think about blogs. You know, really, especially for personal blogs, which don't get a lot of like search engine traffic to them, the old posts, they are very rarely accessed really by anyone or comments. And what people are doing is saying, hey, we should just move it to some iBox with huge hard drives, which doesn't really get a lot of traffic. So what you can do is kind of this double sharding. You shard by user ID, and then you have normal shard and archive shard, and say, okay, all the data which is older than 3 months or whatever is going to be on the archive shard, which is configured for different type of access. You can do full archiving, or in some cases you still keep some of the stuff, like for example, they mentioned the message headers. You still may want to keep them if you want to, do some stuff. As I mentioned, sooner or later you will need to balance the load and moving objects. There are a couple of approaches here. One of them is moving by one object. And let's say you wrote a bunch of scripts or whatever which can extract the user from this shard, making this user read only for a time, and then put it somewhere in another place. It is very nice because it's really non-intrusive. You would only make single user read only, and it doesn't really take a lot of time to move a single user in many cases. But the problem here is that you've got to write a lot of code. You have to really figure out all the dependencies for user and update it there, and this is not really complicated, not really fun. And then also it's relatively quicker to move single objects. But if you need to use like a million or, let's say many thousands of users, it becomes rather slow because, doing stuff in batches is faster. The other approach is by moving the whole table groups. And that's the reason also why I say the small table groups are good. They are manageable. So if I say my server is overloaded and my table group is small, well, I just would mark it table group read only. I MySQL dump it, MySQL import it on this side in 5 minutes, and that's it, right? I don't need to deal with any of these complex code changes. And you know what? I think for many applications, making the stuff, read only for a user for 5 minutes once in a year, or wherever it happens, I mean, it's acceptable. Especially if you do it during the night and stuff like that. What can take care from shard? I think there are a bunch of approaches here. One is database access layer, when you simply would have some information in the API which gets very pretty much past user ID or shard of this main object identifier one way or another, and it routes queries. Another approach is what people simply hide their queries, and that's typical for legacy application, and have some user ID in those queries. People say, okay, well, I have my database access layer, which now does query parsing, extracts the user ID from them, and then would point the queries to appropriate connections, or maybe we'll simply rewrite the queries to change the tables. This is a bit messy, but for all the applications you can make it work, right? Especially if you don't have like ad hoc queries, which can be completely insane. Now, there are some stuff like RDB, HScale, which you can also offer some assistance with. There is a Spoke proxy, another little tool for sharding. There is development going on to simplify things with MySQL proxy. The dormant MySQL proxy is also worth to look at. And as we can see, the sharding is kind of still moving target. There is no solution here, like, oh, if you need to scale the sharding, use this, right? I mean, it's a lot of things, all which have some benefits and drawbacks. And a few more stuff. When you do sharding, some data is global. I don't know, a list of cities, for example, or maybe even a list of users. And you might well like to join the database, right? So what you can do, one of them is say, okay, let's keep it on the separate location and simply code my joins manually. And it's actually not that bad, because by spreading the one query to a serial one, you can often make your caches much more efficient. Because cache from memcache, I mean, if you get it by this, to retrieve single user ID profile, that's likely to be there, but if the same user ID profile retrieved as a 25 different join queries, well, you may not hit it when you run just different join query. Another approach is a replication of global tables. And that's, I quite frequently see, but I don't think I really like it, if it's MySQL replication. The problem with that is, now you have to keep, like, if you also probably want to have redundancy for your box, and you cannot have two master for MySQL. So that means you'll have to have like chain replication, and then your maintenance operation becomes more complicated. But at the same time, replication can mean other things. Like, for example, maybe you simply say, okay, user, or let's say, new cities are not added that frequently. Let me just go there and add it to each of them. Or some people, let's say, GeoIP information, right? Or some other third-party data. Well, why don't I load it to all the boxes at the same time? I mean, simply, right? From external source instead of using MySQL application for that. You can also do the access to the federated engine, but I would be really careful with that because that may break and have some other things. Yeah.
I was running a test with the Linux storage engine. After about a week, I just didn't like the joins.
Yeah.
The data wasn't consistent.
Well, I mean, I would tell you this is like a gray zone. I would tell you fun stuff. We have like one of the customers who does something crazy. He has like federated tables with triggers which connects to views on different boxes, and that is just fun stuff, right? So, I mean, federated. Why I'm putting it here, I will tell you why. Because if I don't, somebody will say, "Hey, what about federated?" And really think the truth is, it works for some people. That is exactly how it is. And some people will tell me, "What the hell, speaking about it's buggy, it works for us. Like we're using it for production for a year now. Good for you, right?" But just be careful because it breaks, and it can also bring your server down. Now, accessing multiple shards. That is another complex, or multiple could be all shards or few shards. And there are a bunch of approaches here. And first of all, let me put it this way. In pretty much any application which is sharded I've seen, there are some global data accesses are going to happen anyway, right? It could be did for like global search, for example, for analytics, for various like rating, who is the most active user, blah, blah, blah. Like friend updates, which is frequently seen in social networks and stuff like that. What you can do here? Well, it could be creating summary tables for that. Let's say, for example, for rating, quite frequently just doing it once per night and forgetting about it works quite okay. Parallel execution, for example, dealing with his friends' updates. There are two approaches, like pretty much mailbox table and getting the parallel query execution on all their shards which involve given user. Both have benefits and drawbacks, and both are used by some people. And also, the parallel query execution is quite crap in PHP. I was quite glad to hear the guys from MySQL and DDriver actually have added support for parallel MySQL query submission right now. So it's going to get better. Loading data for analytics, well, also people often just don't use MySQL for that. It could be either some stuff like NetEase and TickFire getting some stuff done now, or it could be some other system, let's say Hadoop-based system altogether. And then really a lot of stuff can be done with other third-party software. I spoke about Sphinx today, and indeed in a lot of cases when we need global data access, that's very nice. Just put it on the cluster, and it works fine. People use naturally C in other cases. That's everybody uses what it's fine. Okay, we finally got to the end, so that's not too bad. Almost in time. And about caching. Again, my talk wasn't about caching, but and I think it's kind of was. But you need to understand that this is like really important. The whole another direction of scalability. You can do quite a lot with caching, right? And both caching, in terms of like memcache, object caching, like let's say smart caching on the screen and stuff like that. So look at this very carefully. Any questions? Okay, just bored and sleepy, right? Sorry for a long day.
Everybody knows how to shard now.
Yeah. Thank you.